Hello, everybody, and welcome back. Continuing calculus journey. Limits at infinity. Let me cancel this guy. Limits at infinity. So, limits at infinity just have to do with, exactly what it sounds like. It's literally the limit as x approaches plus or minus infinity. And again, and these would be two separate calculations, right? So I was just being kind of lazy just now. The limit as x approaches infinity of some function, and then separately the limit as x approaches negative infinity of some function. Okay, and it's exactly what it sounds like. It's it answers the question, what happens to f as x gets enormously huge. And let's see, can I spell this without messing it up? Enormously huge. There we go. That's what this is all about. Limits at infinity. Let's look at a couple of graphical situations that could happen here. So let's see. Let's look at all the possibilities. Okay, so xy axis. So you could have a situation like this, like for example, the function y equals x squared. Um, in this case, as x gets bigger, you're squaring big numbers, and if you square a big number, it's just going to get way, 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 way bigger, right? So the limit as x approaches infinity of x squared, that's infinity. As you square numbers, they just get bigger. That's all that's telling us. Um, the same is true for just regular x, right? As x goes to infinity, x goes to infinity. Let's see. What else? Right? That's one situation. What about this situation? Here's the exponential, for example. There's one half of the exponential, and then here's the other part of the regular exponential. Right? So here, the limit as x approaches infinity, and if this is the natural exponential, we're talking about e to the x, we can see that this is increasing to infinity, and likewise, not likewise, on the other hand, um, as x approaches negative infinity, we can see what's going on here. The exponential approaches 0. Okay. And of course, this just has to do with laws of exponents, right? So, for example, if I do e to the negative 100, for example, that's, you know, e to the negative 100 is like 1 over e to the positive 100. And remember, e is like 2.7, right? So this is approximately 1 over 2.7 times 2.7 100 times. And so, of course, this is going to be basically then, the logic here is this is 1 over a huge number. And 1 over a huge number is really, really close to 0. So that's the reason why, as x approaches negative infinity of the exponential, we're going to be going to 0. Um, so, these are just a few of the limits at infinity. It's also possible to have a situation like this. So this is going to represent my limit at infinity. Also got a horizontal asymptote, right? So we could have a curve like this. Maybe locally it goes through, but then the idea is is that as x goes to infinity, if there's a horizontal asymptote, it'll get closer and closer at infinity without actually touching. could also have a situation like this where we oscillate, but the oscillations get smaller. So, if the oscillations are getting smaller, 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 then eventually, you won't really be able to see them at all. And this is another way to converge to the horizontal asymptote, the limit at infinity. And yeah, yeah. Like I said, this is just a general overview of just the different types of things that can happen.